All right, welcome back. This is the second part of inequalities in one triangle. And we talked about the relationship between angles and their sides in triangles. And we're going to extend that a little bit today. And we're going to talk about how we can determine whether or not it's possible for a triangle to exist with different side lengths. And basically what needs to happen is in the red box here. In any triangle, the sum of the lengths of any two sides is always greater than the length of the third side. Another way of saying that is that your two smallest sides have to be bigger than the third side. So you can see in the triangle at the left, the two smaller sides are 3 and 3. When you add those together, 6 is greater than 5, so that's why it's possible for that to exist. In the triangle on the right, 2 plus 2 equals 4, and 4 is less than 6, so you can't even get a triangle out of that no matter what you do. With those three side lengths, you can't create or construct a triangle with those lengths. So here's a theorem, 512, the triangle inequality theorem, and basically it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So no matter how you work it, if you take xy plus yz, that has to be bigger than xz, yz plus xz has to be bigger than xy, and xz plus xy must be bigger than yz. No matter which two you pick, it's bigger than the third one. So here are some problems that have you try to figure out whether or not you can construct a triangle with these given side lengths. So part A says 3 feet, 7 feet, and 8 feet. 8 feet. Can we construct a triangle out of those side lengths? Well, if you take the two smallest ones, 3 feet plus 7 feet, that gives us 10 feet, and that's bigger than 8. So yes, we can actually construct a triangle with those side lengths. On the right-hand side, the two smallest ones are 5 and 10. Is 5 plus 10 greater than 15? And no, it's not. It's equal to 15. So that one we can't actually do. Since it's not bigger than the third side, it's not possible. All right, here's a couple for you to try. Go ahead and try letter A and B down here for problem 4. Can a triangle have sides with the given lengths? And explain why or why not. All right, let's take a look at these. Letter A, it says 2, 6, and 9. Well, if we take 2 and we add 6 to that, is that greater than, I should put a question mark in here, is this greater than 9? Well, 2 plus 6 is 8 greater than 9? And it is not greater than 9, so therefore, no, we can't make a triangle out of those three lengths. On the right-hand side, the two smaller ones are 4 and 6. Is 4 plus 6 greater than 9? And when we add those together, we can see 4 plus 6 gives us 10, and 10 is greater than 9. So that is a definite yes. We can make a triangle with those lengths. In this problem, it says, suppose you wanted to build a sandbox, and you've got two boards that are going to make up two of the sides of the sandbox. And one of those boards is 5 feet long and the other one's 8 feet long. What are the possible lengths of the third side? So what's the range of possibilities? There's more than one answer that will fit. And we want to know what are the requirements. What's the shortest and what's the longest that will work for that third side. So we're going to let x represent the length of the third side, and using that triangle inequality theorem, we're going to go ahead and write those three inequalities, and we'll solve each one, and then we'll come up with our answer. So the first one, if we go with the 5-foot section, our third side plus 5 has to be bigger than 8. Okay, x plus 5 must be greater than 8. And remember, to solve inequalities, it's just like solving equations. There are some other properties when we divide by negatives that we'll have to deal with, but for the most part, we can subtract 5 from both sides, and we end up with x is greater than 3. I'm just going to write in here that we subtract 5 from both sides in case you've forgotten any of those inequality properties, that we can solve those just like equations, okay? So x has got to be greater than 3. What about the second set? Well, what if we deal with the 8? Then whatever our third side is plus 8 has to be greater than 5, okay? So this one we're going to go ahead and subtract 8 from both sides. So we'll go minus 8 and minus 8 over here. So then we get these add to 0, and we get x is greater than -3. Well, that doesn't really make any sense to have a length of a side bigger than -3. We can't have a negative length. So x greater than 3 already takes care of this x greater than -3. Well, our third possibility is that the 5 and the 8, when we add those together, have to be greater than our third side x. Well, in this one, we go ahead and add 5 and 8, and we end up with the inequality that says 13 is greater than x, right? We can write it that way. But they just switched these around and said that x then is less than 13. So these are equivalent statements. They are read the same way. 13 greater than x is the same thing as x less than 13. If we were to read this one from right to left, it would say x is less than 13. So make sure that you understand that those mean the same thing. Okay? Here's one at the bottom of our slide for you to try. Go ahead and bring your answers to class, and we'll talk about it in class. See you next time.